finally, in my opinion, we saved the best for last. We are putting things into groups, the fall and the spring, or as I'm going to show it, the not fall. And here's why I show it as fall and not fall. So that if I've got a rule like number 3, if K is in the fall, O is in the fall, when I do the contrapositive, I can clearly see it. I have a mechanism for talking about fall and spring separately and clearly. Not O means O is not fall. O is on this side of my diagram. And if O is on this side of my diagram, then K is also on this side of my diagram. All right, rules are pretty straightforward. M and P are not in the same group. K and N are in the same group. If K is in the fall, O is also in the fall. So if O is not in the fall, K is not in the fall. And if M is in the fall, N is not in the fall. If N is in the fall, then M is not. Let's answer questions 19, an acceptable schedule, and we go back like the other, like the first two of the games in this section to a total accounting of everybody. Answer choice A is false, however, because rule 2 says K and N have to be together. Answer choice B is false because rule 1 says M and P cannot be together. Answer choice C is false because if K is in the fall, O has to be in the fall. Get rid of C. And answer choice D is false because rule 4 says if M is in the fall, N must not be. And yet there they are together, and that leaves us with only answer choice E, which must be the answer. Question 20. If M is in the fall. If M is in the fall, first rule, not with P. P is not fall. Second rule about M, if M is in the fall, N is not. Another rule about N, wherever N goes, K goes also. Another rule about K, oh, but that doesn't apply here. And you see why I like the visual. Like if we had a K in the fall, then I'd know about O, but now I don't know about O. Books that could be published in the fall along with M, not P, not N, not K, but L and O, sure. Question 21. If N is in the fall, what could be true? N is in the fall. All right, N brings K, K brings O, N kicks out M, M can't be with P, and now the only thing we have left is L, about whom we have no rules. So L, well, what could be true? This is probably about L. L is published in the fall. Yeah, sure, why not? Totally possible. And obviously those other 4 not possible. All right, question 22. Schedule is fully determined which of the following is true, and watch how this works. If K is in the fall, answer choice A, and L is in the spring. K is in the fall. L is not in the fall. All right, K brings N. If N is in the fall, M is not. M and P can't both be together. And finally, O is the only thing we don't know about, and we have a rule. If K is in the fall, so is O. That's 1, 2, 3, 4, 5, 6. That's everybody. That's what it's determined. And just for contrast, we don't have to do this, but you know, why not? It'll be fun. Answer choice B, O is in the fall and P is in the spring. All right, if P is in the spring, M is in the fall. If M is in the fall, N is not fall. N and K have to be together. 1, 2, 3, 4, 5, and that leaves us with only L, about whom we have no rules, so we cannot determine where L goes. And that's the difference between determinate and not determinate. Finally, on question 23, a substitution question. And again, I'll go through this. I've talked about this every time, so if you'd like repetition, make sure you watch every other video with the substitution question. Here's how we deal with it. The first prong of attack is that if the right answer is going to be a substitute for one of our rules, then the right answer must be true in every instance so far, because all of our rules are true in every instance so far. And if it's a substitute, it's the same as our old rule. So the first thing we could do, without even bothering with which rule we're substituting for is we could look at answer choices and get rid of things that have not always been true. Like this, answer choice A, if L is in the fall, M must be in the spring. That's just not true. Here, L and M are both in the fall. So since answer choice A was not true here, but all of our rules were true here, A is not the same as any of our rules. It's not a substitute. Answer choice B, if N is in the fall, P must be in the fall. That has been true here and here. Both times we have N in the fall. Maybe that's our answer. Answer choice C, if M is in the spring, P must be in the fall. What the hell? That was already a rule. I mean, that's just rule 1. That does not add anything. It is not a substitute for any of the other rules. Get rid of that nonsense. Answer choice D, if N is in the spring, M must be in the spring. And so far, that's never been true. If N is in the spring, M is in the fall. Both times we've got N in the spring, so that's just not true. It's not. And while answer choice D is false right here, every single one of our old rules is true right here. So D is not a substitute for old rules. So we've gotten rid of A and C and D. Answer choice E, if O is in the spring, N must be in the spring. I've never seen O in the spring. Maybe that's our answer. All right, so that's the first prong. That was the first prong of our two-pronged plan of attack. The second prong is now we actually do have to talk about the rule in question. One of these answer choices in either B or E, since they're the only ones left, is the same as one of the old rules. And the old rule that we're getting rid of is M and N. So this rule doesn't exist anymore, and either answer choice B or E is the same. Well, we have seen now that A, C, and D all are false in places where that is true, right? So let's flip it around. Let's see if B can be true in a place where that is false. So we've done it one way, let's do it the other way. All right, answer choice B, if N is in the fall, P must be in the fall. I want to make this true. If N is in the fall, P must be in the fall. And that's a conditional. Yeah? So I want to make that conditional true. Well, what if I say, okay, N is not in the fall? So we'll hold the contrapositive. P's in the spring. N's in the spring. Now P and M, they have to be separate. Oh shit, that looks just like our old rule. Our old rule is true. Okay, what if I do it the other way? What if I say N and P? Because if N is in the fall, P is in the fall. And then rule 1, P and M. Oh, again, it looks just like, if I make this rule true, I end up inadvertently making that rule true also. They're just the same rule. Contrast that against answer choice E. If O is in the spring, N is in the spring. All right, let's make it true. I don't know why I'm starting with the contrapositive, but I am. It doesn't matter. If N is in the fall, so is O. So that's true. Now, I've made this rule true. I want to make this rule false. This rule said that if N is here, M is out. Let's put M in. All right, M and P are separated. K and N are together. If K, then O. That checks off. Look, everything works here. Answer choice E is true if O is in the spring, N is in the fall, or by contrapositive, if N is in the fall, O is also there. Rule 1 is true, M and P are separated. Rule 2 is true, K and N are together. Rule 3 is true, K and O are together. And rule 4 is false. So answer choice E is true, while rule 4 is false. Answer choice E is not the same as rule 4. It is not a substitute. Get rid of it. And that closes out this game, and that closes out this game section.